everyone. I am Tevos, Matevosyan. I work in KMI and we have an R&D center in Yerevan where we also have a data center. So, in general, not complete. It is quite a big model, multinational corporation. So, and it's not a matter of the like otherwise. So when working in such organization, you end up with a bit of different kinds of challenges in some cases, and this is one of the things that I thought would be interesting for because nowadays it's very popular. Like banks hire data scientists, other non-tech companies hire data scientists. So I guess some of them might face the same challenges that we face. So I decided to share a bit of experience from there so that maybe it will be. Now, as I said, we have an R&D center in Armenia. There are quite a team of data scientists working there. Now, this is something new. Previously, there were a few of us, and at some point, we were working with certain teams based in Neuchâtel, the main R&D center, where we would work on ad hoc requests. It could be, hypothesis testing or some analysis or stuff like that, directly with I don't know, people, engineers, firmware people, and other people who are not necessarily from anyhow related from machine learning or data science. Now, for these people, in certain cases, you end up you face the issue of the interpretability because they want something, they want some analysis, they want some process to be explained, but they don't necessarily want you to give them a model that predicts something. They really want to know how it works. Now, that already starts. So not feature importance, not the heat map, but how exactly does this model predict that this belongs to this particular class or the other. Now, this is coming partly, this is because of, it could be also distrust towards ML models because there are varying degrees of imagination about how the ML works. And on the other hand, there is also the case that, okay, they want to have this, they don't necessarily want to have a moderator. They want to understand something from the actual data. Now, so at some point, I will go concentrate on one use case, which kind of laid the foundations for the project that we are doing now, and that is where we face this issue. Now, imagine a data set where you have sequences of categorical variables. Now, and each sequence is marked with some particular label. Now, for the simplicity, I went with binary one because it's much more faster to go around within the limited time. But so just and so yeah. But in reality, it was a multi-class problem with certain data balance and many other issues that was faced with real data. Another interesting thing here was that so this is not the real data, by the way. There are two reasons why I didn't put the real data. First, because it's not public. Second, because the feature names are terribly low. Like, even if it was public, I would put it because it's horrible to read all these features. Now, what theoretically you could do? So they gave us the data. They said, okay, we need more or less to do something like this. That we give the sequence. Then the algorithm says, okay, this belongs to this one, this belongs to the other one. So that we could just predict the label. Now, we thought of several ways. One was basically to do some preprocessing, make the sequence into something tabular, and then run tree-based estimators on it. And the other was, go with sequential neural networks, mainly RNNs. In the initial stage, we said, okay, we can do this, these have higher accuracy, these have a bit lower accuracy, but are easier to implement. But they said, basically, so give me something simple that I can query in SQL and understand how it works. I mean, I guess many of you, all of you have worked with SQL. There you have certain limitations on how to. Okay, in theory, you can even, I guess, build a PCA with SQL. I haven't done it, I guess I'll debate you. But it's a hell of a lot of work. So this is kind of the constraint that we had to meet at the same time, try to give some kind of description, some kind of classification for these kind of things. Now, right away, you forget about target encoding, you forget about anything much more complex than simple counts or ratios. So, one other reason, so besides the trust, one other reason for this kind of constraint was, okay, this data set was not initially, I would say, grasped for us. It was a data set that firmware engineers and other people were working with to identify certain issues coming from. So just for you to know, these are kind of machine loads. Some loads come from some network equipment. So for the firmware people later to debug and understand what's the problem, but so they ended up having a bunch of this data, so they turned to us. We had to do this process alone. Now the first thing we did, so we went into theory because like simple rules with SQL, okay, sounds good, but how can we do? We went into the theory, and it turned out there are quite a lot of things. There's quite a lot of research on that. There are ways to extract this kind of, I guess, some rules from neural networks. They do hypercube selections from SVMs, and but more or less the easier ones, I mean the ones that are well implemented in the package, are the ones that are based on triad samples, mostly padding classifiers. We researched the field, found found several more, but the good usable ones were these three packages. This scope rules is a scikit-learn based classifier, so it is basically works like a scikit-learn. H2O's the rule fit algorithm independently is an algorithm of well referred in theory of rule extraction, so H2O has its implementation of it. And this Wittgenstein is a bit of a project on its own, where they have implemented two algorithms again, quite well documented in literature. Now, I don't know how well visible it is, but so this is example on the iris dataset, and what you see here, the pattern length being less than 4.95, and pattern length being above something, etc., etc. So it's something that you can really just fire with the SQL. One issue with these guys is that this algorithm, as it is based on a backing classifier on decision on multiple decision trees, it doesn't have an OR condition here. H2O and Wittgenstein implemented some OR condition on some basis. Now, why do you need an OR condition? Is because with AND conditions, with AND clauses only, you end up having sometimes big precision and too big in comparison. So you end up having quite low recall rules. And that is sometimes an issue. Especially, I mean, if you imagine the below data set where you have certain blocks in some scatter plot, apparently the algorithm is going to perform either carryable or extractable for only one of these blocks. Now, this is something that we didn't really have. Then, so let's look at how these algorithms in general perform. So, first, the data set, like we remember, it is kind of a sequence of categorical variables. Now, the initial thing we did, we went with very simple group by the category type, the variable type inside it, and just have it count for it. I know it's simple, but the simpler it is, and easier it is then to verify with SQL. The performance is, this is the performance of the synthetic data set that I generated for this presentation purposes. Now, more or less I'll go in detail, but it is comparable to what we saw in the real data set. So, scope rules is performing a bit better on this in terms of recall than it used to do on our data set, because I think I wasn't too much of pushing the data set to be like a blobs in the scatter. The rest are more or less similar in terms of the performance that they were generating. Now, throughout all this time, when we were showing this result, discussing this stuff, we were always showing a page marker on the same transformation of the data set, particularly we went to the random forest classifier because the nature of the data set was such that weak learners of boosted trees were not sufficient to have as much accuracy as a strong learner of random classifier would have. So basically any boosting algorithm we tried was underperforming in comparison to the random classifier, or the next random classifier gathered less papers, but more or less doing the same job. So we are always showing this thing in the background because we're always saying, guys, okay, if there is a problem that needs to be solved by an ML, let's go and do it with an ML. But once you step into, you know, the actual ML, the interpretability becomes a bit of a, not at the level that they would like to have. So I don't know if anybody has tried to run the decision path function of random forest and look at the outputs. Yes, you see what that is. And you would rather not do that. So we were always showing you the background, and as you can see, I mean, obviously a pure ML model, I mean, the neural nets definitely are going to have much higher accuracy, much better generalizability than our depends, but than a single rule that you can verify with the SQL. So, but still, like, in case anybody at some point decides to use this kind of rule extractors, let me go one by one. What are the perks with each of them, and what are the good things about them? So we ended up using this one because first it had decent accuracy and it had a good integration. I mean, the rules that were being extracted from the classifier were quite good to then directly translate into SQL or just use the on the data frame query method. It was just a string you could put into the query method and do it immediately, get the results immediately. Now, one issue with the scope rules classifier was that, so it is giving you a list of rules. Now, the first rule usually would have decent precision, but terribly low recall. But not terribly, but you know, not a decent recall for our data set. And this was something that, you know, was a bit problematic. The H2O's implementation is nice, but still, if you are if you have more or less a how to say scikit-learn type oriented stack, you end up having you know, not developing, but kind of wrapping your classifiers or any other objects around the scikit-learn type API so that you don't really try to separate code for one and the other and keep the original one for the scikit-learn classifier. So everything, but the good thing is that, well, it's H2O, it's quite powerful, it has its own server running under data, and this is classifier, so it's not bad. Now again, the bad thing again is that it is an H2O. It's not a purely Python-based thing, so you end up really having to do some stuff in the code to adapt it to the stack. Now, and the rule syntax that it was extracting was a bit terrible. Then we had to do some post-processing on the rules. And why is it terrible? Because like it was giving some ranges and stuff like that, which needed some extra attention so that we could run all this stuff in a pipeline. Because we were doing this over, we wrote some pipeline that was doing this, how to say, comparing these three algorithms and then, you know, see the result in parallel. And the Wittgenstein is very nice package. They kind of came up with a structure of their own, which is very nice. Just as an idea, the bad thing is that, you know, it is a, how to say, it has an API of its own, so which kind of makes you think, okay, guys, why did you write a different name for one rather than things? Because, you know, everybody else likes things. But it is the way they wrote the classifier is completely independent. So if you dig into the GitHub repo, these guys, it is more or less you see a kind of familiar structure. These guys, well, they are a bit unique, but it's very well reflecting the theory papers that I showed earlier. So more or less what you see, what equations you see in the theory paper, I can't say they duplicate it, but they try to stay original to the theory as much as possible. Now, it has or condition rules in it, which are implemented in some way. In our case, it was a bit too much of a problem because it was overfitting. And the rules syntax is, I mean, it's really terrible. Then you have to write a separate process that translates the rules of these guys into SQL. I mean, if you don't need to translate it into SQL, it's good. Without constraint, you really have to work a lot to make this classifier fit. Now, okay, these are their these are their raw scores in comparison to that. Now, but this alone was not enough to have a full coverage of the question that we were asked. So the question is, let's go back. So you have the sequences, categorical features, and you have the labels. So try to classify the labels as accurately as possible, and at the same time tell us how exactly happens that give the sequence and the classification of this result. So we did two kind of additions on that. One is introducing an OR condition for scope rules. We went with a greedy approach, and it was kind of why we decided to go to this one. So we were always benchmarking with the random forest. We would just see that systematically for certain classes the precision was okay, but the recall was terribly low. So I mean, the only thing that would solve this is basically to include an OR condition, because with AND conditions you are always going to minimize the selection, make it smaller. So we ended up using one. So now, from the very beginning, it gives you a list of rules. Now, to find the best combination, it is a combinatorial optimization problem, which is not an easy task. We went with the greedy approach. Basically, we would sort the rules by their F1 score, then calculate, then join them cumulatively with the OR condition, and then calculate the differential in the F1 scores that we were getting after adding each one. And after a certain threshold, if it was above a certain threshold, we would join the first one or the second one. I mean, the first one and the second one with the OR condition. Now, greedy approach, nice, quick, but not really guaranteed to, not really always giving the best solution. So we had Rafael, our intern, who, so unfortunately he's not with us anymore, but on the kind of his last days, he said, okay, what did I do? I said, okay, can you kind of prove that, okay, can you kind of come up with some mathematical formulation for this? And he came up, so thanks to him for that. Now, still it was not bad. We were getting already scores comparable to the random forest, because so with this approach, the good thing was that, of course, we were getting a drop in the precision by adding new rules. Still, the overall F score was not suffering, because I mean, we had this kind of threshold for it. Now, the other thing we did was, so if you remember, the data was sequences. So this thing had to be somehow considered, because initially there was a reason why they were sequences. Now, how to incorporate sequences into the rules? I mean, how to make these classifiers that are for tabular data sets to kind of also represent something sequential. Okay, this is multiplication. What did we do? For each class of the sequences, we calculated the kind of the transition matrix between each categories. So, like, wow, okay. So something like what is the probability for that subset of sequences to jump from E to A, or then from E to I, or something like that. I don't know, something like a Markov chain, like Markov matrix. We have seen that. Now, then we would, and then this matrix's internal terms were normalized by the general probability of such sequence occurring in the general population. And then these two matrices were, we took the absolute difference between these matrices and then applied the mask on this matrix. So essentially, we would end up with a binary matrix, and then the binary matrix which would tell us, so if we end up with something like this, then we would generate new features which were A next B because it is 1, and then B next B. So this kind of how to say duplicates in the sequences were happening, and this was something not kind of dirty data or something, but it was something how to say having a reason for it. Now, after doing this good stuff, we kind of presented these results to these guys, our team, and they were more or less happy. But the good thing was that, as we were always showing the benchmarker in the background, they said, okay, now we have convinced us, let's move to proper ML. Now, what we did next was we deployed proper ML models. Basically, bagging classifiers were now stacked with one more classifier on top of them. Now we are moving towards doing RNN on that, because the data kind of wants RNN more or less. How to say, tested, went through it. It's better if we move to such kind of a solution. Now, and there were several encounters with this throughout this process with the firmware engineers that show somehow that, okay, these rule extraction classifiers are not good, but they are not terrible either. One of them was that, so we are presenting these results, we send them the rules in SQL, and so, like, wait, I didn't know how it was generated. So let's say there's a condition in the rule that, okay, this call must be not more than 21. So this guy went and started to play the DB around this 21, and then the next day he says, guys, I don't know how you generated this, but I mean, no matter how I play with this number, it makes everything worse. So then we said that that is actually the best split line from the decision tree. So I mean, there's only one best split line, so you can't make it any better. The other one was that, so at some point we stopped looking inside the rules because those were at some point excessive SQL codes, strings. And then during one discussion, so we always thought it's just the best split line. There is no, it's just statistical rules, so there is no, how to say, good background behind it. So let's say there was some column C that the rule wanted it to be above 6 for a certain type of label to be true. Then one of the firmware guys then says, oh, okay, I know why it is 6. I say, what? And he says, yeah, because in the firmware initially it is encoded that if it is above 6, then there is a failure. And we're like, okay, so it's not just statistical, there's something also meaningful behind it, always expected, very good, right? And then at some point there was another kind of fun incident. So there are, as I said, it's a multi-class problem, and one of these classes, we were discussing one of these classes, and this guy said, guys, I don't know how you managed to classify this class, but it should be either G or F happening in the sequence so that it is, so that this problem happens with that sequence. And then we are looking into the rule, and with these 4 conditions that we had generated, it was explicitly saying that either G or F are occurring in the sequence. That's why this particular label is true. Now, okay, it's as classifiers, they are really weak. I mean, come on, it's just a single branch from the very top to the very bottom from decision. What can you expect from that when, in general, you do hundreds of decision trees to come up with something this? But in terms of interpretability, they are perfect. Now, other uses we used those for was at some point we were tasked with some clustering, etc. And then there were like n clusters, and so to describe these clusters, these algorithms were very good because okay, you get 6 clusters in the next what does this mean? Then to describe like okay, this cluster is where let's say this column is low there, the other one is high. This was quite useful. Still, not an RNN, but something we can kind of get. And but the real nice part about this was that so it kind of paved the way because these firmware people and the other guys in the organization, they were kind of somehow to give approval that what these guys are doing, what this ML stuff is valid, so it's not some trickstery or it's not some Skynet trying to kill everyone else. Just, okay, whatever they're doing is legit, so let's give a green light. And as I said, then we move to a proper timeline. So we don't do rules now, just once time reminder, so we don't do rules in game anymore. I mean, we do it, but for fun. And as I said, for the uses, again, like, you can classify with a pretty complex classifier, then run this kind of algorithms on top of the already predicted labels and get some kind of a nice feel of how it works, wherever it's applicable. And this is it. So thank you all. In case of any questions, please go. Yes.
Actually, two questions. First one is, what type of algorithms are you
This is mostly so mostly with this one, but it is mostly it's a classification random forest regressor, namely the random forest regressor and random forest from the scikit-learn.
So it's trying to be on
Yes, and then there is some additional process which selects a single branch. I mean, maybe it's not the right term, branch, but something that starts from the very top, from one of those tree classifiers inside it that is giving the highest outcome score.
And the second question is, if, for example, one rule, there are one rules, right?
Yes.
It's not given out one. So if, for example, there are two rules, and one of the rules for the given data point says that it belongs to class 1 and the other one says that it belongs to class 2, how do you calculate the
actually, yeah, a good point. Sorry, I forgot to mention, because we have this limitation to use it in SQL. It gives like hundreds of rules. So, we wanted something to be usable. We took only the top rule. We were always using only the top rule. So, sorry, I forgot to mention this, but so these are all scores for only for the first rule from the classifier. Now, why not the full rules? Because then we have to write a SQL script that we could read and understand what the hell is written there.
If you send them all the rules, you could actually make that.
Yes, that's true. But then it would become less readable, because especially with our feature names were terribly long and they had a reason for being so long and we didn't like it. So it was becoming a script that you could read, but really grasping it was too much of an issue. But you are right. If you actually use the predict method of that class, not the single rule query, it is very comparable to any bagging classifier. Because, yeah, basically it's bagging classifier. Other questions? Yeah.
So yes, you mentioned that there was a slide where there was a value in one of the columns, and you said you found that it was above a threshold.
Yeah.
So that was a surprising thing, but then you realized that that was actually was encoded, and
yes.
My question is related to that. If you have a large, a relational database, sometimes there are these kind of encodings which can become a data leak. So your target, which you are trying to predict, can actually be in some way encoded in one of these columns, which are supposed to be an ID column or something like that, but in fact it's not. They're encoded in some way. So do you have how do you deal with this? What's your experience with dealing with kind of making sure that there are no data leaks?
We kind of have so when I say running this algorithm, it's not just that we import a class and then you will feed predict. So there's a quite properly set up data integration process, and then there's certain pre-processing. It's actually, what I'm talking about is actually a pipeline, not so now these things are happening. Now, No, okay, but I'm sure that this is not that. The ID one we are sure because the ID code was a terrible code. So if it was that one, we would really get the artifact right away. Thanks.
This use case was good to identify some systematic patterns. Maybe if there is a leakage, you can find it.
Yeah, yes. We will also see it. See. No, this is it.
And any last question for Tevos?
Yeah.
Please go ahead.
So are am I concluding right that you are using mainly Ethereum trees?
So for that particular task, where this was the first time we were working with this team, and they were a bit, like, who are you exactly? What is it about? I mean, we don't trust you. Well, they didn't say we don't trust you, but in a sense, I guess they did. Now, for that particular task, yes, it was all decision trees going there.
Did you try any other way to
Exactly.
the rules?
Look, we wanted to go, in the beginning we wanted to go with this SVM hypercube selection, but the initial issue with the SVM was that the dataset was huge, being honest, and the number of features are actually somewhere like 80, something like that. So we went with this one because it was fast and it was quickly giving the result.
In any other solution, you will have to re-implement that in the SQL coding right?
Also, that is true, yes. If we, now, okay, a hypercube's coordinate would be something implementable, yes, perhaps. I don't know. Like, we didn't really went that far in implementing this SVM one because right away you start with the problems of SVM.
So are you limited with SQL?
No, just the database that they had and we had that we were sharing was the SQL database, so they wanted something to verify on their side, so that's why we, but in reality, we, just for the record, we use the stuff for other purposes. Stuff like this.
Are you aware there is such thing that calls business rules management system? It has embedding expert system that is much more powerful than SQL and many programming languages.
Yeah,
You
like,
can
I imagine.
use
I
that,
imagine that.
embedded rules.
The thing is, we use the stack that the company is setting up, so they are a bit difficult.
What I